Last type of equations for section 1.6 are absolute value equations. And you guys have done these in Algebra 1 and in Algebra 2, so they should be fairly simple. And just like we saw when we had radical equations, we needed to isolate the radical. Well, in absolute value equations, we are going to isolate the absolute value expression. So of course, the absolute value expression is here. So the first thing we need to do is to divide the 3 away. Remember, that's 3 times the absolute value of 2x minus 1. So goodbye 3's. That leaves us with the absolute value of 2x minus 1 is equal to 7. So consider the definition of absolute value. How far a number is from 0 on the number line. So in our problem that we have 2x minus 1 in the absolute value bars is equal to 7. Well, if on the number line, 0's in the middle, 7 is to the right, negative 7 is to the left, the absolute value that is equal to 7 could be positive 7 because that's 7 units away from 0, or the absolute value that's equal to 7 could be in the negative direction because that's also 7 units away from 0. So what that entails is this. We have to consider 2 cases here. We have to consider that 2x minus 1 is equal to positive 7 or 2x minus 1 is equal to negative 7. So when we're solving absolute value equations, we are going to consider 2 cases every time. And we will be getting 2 answers in this particular situation. So 2x minus 1 equals 7. That's 2x equals 8, which means that x could be 4. Or 2x equals negative 6 and x equals negative 3. Both of these numbers will make this equation true. Let's give it a quick check. So first the 4 going into the original equation. So 3 times the absolute value of 2 times 4 minus 1, does it equal 21? Well, inside the absolute value bars, follow order of operations always. So 3 times 8 minus 1 is 7, and the absolute value of 7 is 7, so 3 times 7 is 21. Yes, it checks. Let's do it again with the negative 3. 3 times 2 times negative 3 minus 1, does it equal 21? Follow order of operations, go inside the absolute value bars first. So 3 times negative 6 minus 1, and of course negative 6 minus 1 is negative 7, and the absolute value of negative 7 is 7. 3 times 7 is 21. It checks. So both of these answers make this equation a true statement. Therefore, they are both valid. Next, negative 1/2 times the absolute value of 4 minus 5 over 2x plus 6 equals negative 18. We're still going to use the same strategy. We're going to isolate the absolute value expression. So to do that, we will move 6 to the other side. So negative 1/2 times 4 minus 5/2 x equals negative 18 minus 6, negative 24. Now, as it stands, we have an absolute value set equal to a negative number. According to the definition of absolute value, if an absolute value is set equal to a negative, then there's no answer. However, we still need to get rid of the negative 1/2. Remember, the negative 1/2 is multiplied to the absolute value. So the inverse operation of multiplication by negative 1/2 will be multiplication by its reciprocal, which is a negative 2. So negative 2 times negative 1/2, they cancel, and we end up with 4 minus 5 over 2x equals negative 24 times negative 2, which is 48. So we have isolated the absolute value. We've isolated the absolute value, and now we are going to set up our two cases. So 4 minus 5 halves x equals positive 48, or 4 minus 5 halves x equals negative 48. We do both because positive 48 is 48 units from 0 on the number line, or negative 48 is 48 units from 0 on the number line. So we're looking for two valid solutions for x that when we plug them in will make the equation true. So we've got to solve both of these equations independently. So move the 4 over, and we get negative 5 halves x equals 44. And once again, we're going to use a reciprocal in order to solve for x. The reciprocal of negative 5 over 2 is negative 2/5. Yes, reciprocals have like signs. So cancel, 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 cancel. We get x. And then we have 44 times negative 2/5. Now, nothing's going to cancel here. We are going to get a fraction for our answer, and fractions are our friends. So 44 times negative 2 is negative 88 over 5. On the other side, minus 4, negative 5 halves x equals negative 52. Use that reciprocal again, negative 2/5. So all of these cancel, giving us x. And then on the right, negative 52 times negative 2 is positive 104 over 5. So these are our two solutions, and both of them will make the original equation true. So steps to solving an absolute value equation. So first step, isolate, forgot my O, isolate the absolute value, set up two cases, solve for the variable. There you go, solving absolute value equations.